And what I will do for this test, in order to make it interesting to the previous test where I was using a slippery surface traction control and my tires were at low pressure, you can see the video here in a pop-up link. I will instead now, I will go to vehicle dynamics and I will keep the traction control in auto. And the tire pressure, let me see what's the tire pressure right now. I especially for this test I aired up the tires a little bit. So yesterday when I arrived it was 2.9 and 3 bar respectively. That's what Tesla recommends, and we will drive with this normal recommended tire pressure. So I have just arrived to my work site, and let's check first of all that the tire pressure has increased. As I told you last night, I aired up my tires, so it's even a bit more than Tesla recommends. Temperature outside here is a bit irrelevant because I just left the tunnel, but on my way the minimum was minus 21 degrees Celsius, average was, I would say, around minus 17, and the warmest was minus 8, minus 6 for like 3 minutes. Okay, then since charge 96.5 kilometers and average 234.8 watt hours per kilometer, and that is considering that the roads are clean and there is no more snow. The last time it was snow was like 3 weeks ago, so, and whatever residues were on the roads, that everything has melted, so the roads were clean, meaning that I was able to keep a higher average speed. And of course I was using air conditioning. In my previous review, you can check my reviews in a pop-up link there at minus 17, like a month ago. One of the comments was like I set very little temperature in the cabin on air conditioning, kind of trying to save some energy. That's not true. I work at these temperatures, like it's dropping, it's minus 3 and it's gonna be minus 6 here during the day. So I have a long sleeve base layer, winter base layer, warm with the collar, and very dense fleece jacket, and also I'm wearing the underpants, so maybe the base layer under my winter pants. So I am very well I'm fully in the winter clothes in my car, so why would I need 22 or 23 or 24? I use typically 20, sometimes 19 degrees Celsius in my cabin, and I'm very comfortable. And the consumption was 235.2 watt hours per kilometer since charge. So I will stay outside. Okay, let's check time. Now it's 11 minutes past 10. I will probably stay here for another 5 hours. State of charge now is 66%. I will come back after roughly 5 hours. We will check what will be the state of charge, how much it will drop, including the decrease for the preconditioning before I sit in the car and continue my drive. And I see you in the next slide. Alright, I am back in my car ready to go home, and let's get the information. What is the temperature? Minus 6 degrees Celsius, and almost 7 hours later, just 6 minutes shy of 7 hours since my arrival, and after preconditioning, the battery state of charge dropped from 66 when I arrived here. It was 11 minutes past 10. It was 66%. Now it's 61%, and I was preconditioning. It's nice and toasty. I can actually decrease the heated seat. And I will go home the same route. It will be again like 96.5, most likely 100 kilometers, because I will stop by the store, So far consumption 235.5 watt hours per kilometer, and the temperature is gonna be from -6, what is now, and this is the highest temperature, and it's gonna be around -20 on my way. And I will and my tire pressure, let's see, 6 hours ago, that was the tire pressure, 3 bar. It's even a bit more than Tesla recommends, but still within the range. It's not a low tire pressure, and that's the point of my video, to record the video where I will try to compare the consumption of Tesla Model Y Juniper dual motor with a different tire pressure and with different traction control mode, because I was driving here with the traction control in auto, and I will keep it in auto all the way until I go back home, and compare how does that compare to driving in traction control. Slippery surface on snowy roads with basically always engaging both of the motors, and with the tire pressure being much lower. When I was testing last time, it was 2.7, 2.6 bar. But with the snowy roads, the average speed is way lower, and now the roads are clean and I can have much higher average speed, which increases the consumption, and at the same time there is a less rolling resistance to my wheels and tires. Unlike in case with the snow. So in the snow I drive slower, but the car experiences more resistance from the snow. Now I drive faster, but the roads are clean. Okay, I will update you after like 100 kilometers. Stay tuned. So quick update, I am halfway through my return trip. It's 53.4 kilometers since I left my work site. Temperature outside dropped to -21 degrees Celsius. Roads are still clean. Of course, they're slippery. It doesn't mean that they are not slippery if there is no snow. Of course, they're slippery. And consumption is 242 watt hours per kilometer since I left home. Okay, and I still use chill mode, and I still use traction control dynamics in auto, and I think this is the lowest what is gonna be on my route back home. So stay tuned. After I arrive home, I will update you for the final time after like a 200 kilometers round trip at these temperatures, around -20 degrees outside, with a properly aired up tires and with clean roads without snow on the roads. Final results of my test today. I have just arrived home. Total distance for today 201.8 kilometers, and consumption 241.7 watt hours per kilometer. The temperature here is -14 degrees Celsius. Remaining state of charge 23%. Worth mentioning that last hour I was running around the neighborhood, and I was leaving the car outside with the keep climate function enabled, but it doesn't matter much. So overall consumption after driving 201.8 kilometers, I have consumed 48.8 watt hours per kilometer. I think this is the highest consumption I had so far in the winter drive, because the temperature was the coldest, up to -21, and I was driving with a high average speed because the roads are clean, and of course I have some cargo in my car as always. However, the tires were aired up properly. Now, just like couple of kilometers before I arrived home, I was on underground car park, and I dropped down pressure in my tires again because I still prefer more comfort. I don't necessarily anyhow tied up to drive at 2.9 or 3 bar. Overall, so it's a really efficient car, even at minus 20, even at high average speeds. With traction control being in auto, that was main idea of this test, to keep the traction control in auto. And I have, by the way, I have the bigger diameter wheels overall because I'm running Hankook studded tires, non-EV specific, and the dimension is not the Tesla original OEM dimension, that is 255, the same widths, but the profile is 50% and the diameter of the rim is 19 still. So the overall diameter of the wheel is higher, so meaning that this is not 201.8 kilometers, but this is something like, let's say, 205. It's a little more distance because of the overall bigger diameter of the wheel, and there is no possibility in settings here in menu to adjust for the different size of the rims and overall higher diameter of the wheel overall. So pretty much the same result, very efficient car. It's really hard to go beyond 250 watt-hours per kilometer. I mean, even with the studded tires, with the bigger wheels overall, at minus 20, with the car being quite loaded with the equipment and with the quite high average speed in Norway. Thank you for watching. Smash like if you do get value from my videos. Check out the links popping up in the corners of this video. Go in the description section of this video to check my other channels, and consider subscribing on my channel Tesla Impressions, and I will see you in the next video. Thank you for watching. Bye.